What's up, dogs? Today we're going to determine R and S stereochemistry. I have 3 problems here that we'll work on, and at the end of the video, I'll give 3 more practice problems, and the key of which will be posted in the description. Now, in order to determine stereochemistry, you have to have a stereocenter with wedges and dashes. So after you found that stereocenter with wedges and dashes, we're going to prioritize the 4 different groups by atomic number. The higher the atomic number, the higher the priority will be. So if you have hydrogen as one of the groups, it will automatically be the lowest priority because hydrogen is the lowest atomic number. Prioritization is based on first difference. I'll get into that in a little bit. And pi bonds count as multiple bonds. Again, I'll show that in the examples. After we prioritize the 4 groups, we're going to rotate the lowest priority to the back, meaning we're going to put the lowest priority on the dash using a method called enantiomer switch. We do this because when we draw the arrows, we only connect 1, 2, and 3, and since that 4th priority is in the back, it's kind of ignored. And so if you rotate clockwise, we're going to give the stereocenter an R stereochem. And if you rotate counterclockwise, we're going to give it an S stereochem. Let's find the stereocenter with wedges and dashes for our first problem. Here is the stereocenter, and I'm going to draw in the hydrogen on a dash. Now, this stereocenter is connected to a sulfur, a hydrogen, a carbon, and a carbon. With that, sulfur will receive the highest priority because it has the highest atomic number, and hydrogen will receive the lowest. To determine second and third priority between the 2 leftover carbons, we have to see what else they are attached to. This carbon is attached to an oxygen, while this carbon is attached to another carbon. Oxygen will receive higher priority. So next, we're going to rotate lowest priority to the dash. Luckily, in our first problem, it's already on the back. So all we have left is to draw the arrow connecting 1, 2, and 3. And as you see, this rotation is rotating counterclockwise, so it is going to have an S stereochem. Let's find our stereocenter with wedges and dashes on the second problem. We only have one, which is right here. You might think that this is also a stereocenter, but it's not due to the fact that these 2 methyls are the same. So I'm going to draw in the hydrogen on a wedge. And this stereocenter is connected to an oxygen, a hydrogen, a carbon, and a carbon. With that, oxygen will receive highest priority, hydrogen will receive lowest. And this carbon is attached to 3 hydrogens because it is CH3. And this carbon is attached to 2 H's, but it is also attached to a carbon. And what I said earlier about first difference is you can see that this carbon is attached to an hydrogen while this carbon is attached to a carbon. So this will have priority. Next, we rotate the lowest priority to the back. The lowest priority, the hydrogen, is not on a dash right now. So we rotate using a method called enantiomer switch. And all that is draw the backbone of the original compound. I will keep the bromine and the methyl group the same because we haven't done anything with it. And we will also keep the stereochem the same. The only difference is in the original compound, the alcohol is on a dash. Now it will be on a wedge. Priority will stay the same. And now we can draw our arrow. And we see that it is rotating counterclockwise, and so that is an S. If in the enantiomer it is an S, our original compound will just be the opposite of that. So our original compound will have an R stereochem. Let's find the stereocenter with wedges and dashes on our last problem. Here is the stereocenter, and it is attached to an oxygen, a carbon, and a carbon. Oxygen will take highest priority. Next, we see that this carbon is attached to a nitrogen. This carbon is attached to 2 hydrogens. And this carbon is also attached to 2 hydrogens. So the carbon that is attached to the nitrogen will have second priority. These 2 carbons are the same CH2s, and so we have to move on to what else they are attached to. We see that this carbon is attached to a double bond. Double bonds / pi bonds count as multiple bonds, so just think of that as a carbon being attached to another carbon. And this carbon is attached to 2 hydrogens. These carbons will have higher priority because you have carbon has a higher atomic number than hydrogens. Next, we're going to rotate lowest priority to the back. You can draw out the enantiomer like I did in the previous problem, or there's a little bit of a shortcut, and that's just to draw out the numbers. So I'll draw them out as you see them right here. It is 3, 2, 1, and 4. And we will keep 3 and 1 the same, but we'll switch the 2 and the 4 because the 4 is trying to get on the dash where the 2 is right now. So we'll draw our arrow. And this is rotating in a clockwise, so we'll give it an R stereochem. Thus, in our original compound, it is going to be an S stereochem. It is the opposite. Here are the additional practice problems. The key is posted in the description. I hope that helps. Thanks for watching, and I'll see you next time.